Hey everyone, welcome back to my channel. We will be starting an algebraic lesson series, and today we will commence with simplifying algebraic expressions. Before we begin, please click the subscribe button below if you're new to this channel. And for those of you who've been here before, welcome back. And as usual, get your books, get your pens, and let's get going. We will now begin with indices. Indices are usually numbers that go to a certain power or is square rooted by a number. For example, 2 to the power of 2 or square root of 16. Our first point, if we have a to the power of x multiplied by a to the power of z, our answer would equal to, providing that our bases are the same, a to the power of x plus z. So we add the powers together. That is, providing our bases are the same, a, and we are multiplying them. Second point, if we have a to the power of x, and that is bracket multiplied by another power, which is z, we know that our x and our z would need to be multiplied according to brackets, BODMAS or BIDMAS. Then we know that our answer would equal to a to the power of x multiplied by z. Quite simple, right? Our last point now, similar to point 1, instead of us multiplying, if we were to divide, we will have a to the power of x dividing by a to the power of z. Once our bases are the same, a and a, then we would just need to subtract. So instead of adding where we did with the multiplication, we now need to subtract. So we'd have a to the power of x minus z. And that is how we can use indices to simplify our algebraic expressions. We will now move on to how to solve an expression that is being squared. The method that I'm going to show you is not only applicable to if we have a squared expression, but if it's cubed or it's to the power of 4, 5, etc., any number. Our expression is 2x squared y to the power of 2. The first thing we're going to do is write all of our various aspects of our expression separately so we can simplify them, okay? So we have 2 to the power of 2, x squared to the power of 2, and then we have y to the power of 2. We're now going to simplify those steps as simple as we possibly can, okay? We now have 2 squared, which is equal to 2 times 2, 4. We have x to the power of 2. And from what we know from indices is that is x to the power of 2 multiplied by 2. And then we have y squared, simple. We've already simplified our 4. So we can simplify our x squared times 2 a little bit more. So we have x to the power of 4, which is 2 times 2. Our y squared is already simplified. So our answers now, it's already simplified. So we just need to take our various values, which is 4, x to the power of 4, and y squared. And our value, or our final answer would be 4, x to the power of 4, and y squared. And that is our answer. Moving on to negative and fractional indices. A negative indice is, for example, 2 to the power of negative 3. We have a to the power of negative x, and that can be made positive by writing 1 divided by a to the power of x. Moving over to our right, we will simplify how we convert a fractional indice to a normal number or expression. If we have a to the power of half, substituting a value 16 to the power of half, we can then write square root 16. Our denominator 2 then goes into that root there. That is the same because square root and 2 is the same. So we can rewrite that as 16. And we know square root 16 is equal to 4. Going back to our left, we can now see if we have a to the power of 1 over n, that can be simplified by writing square root a, and we know our denominator n goes into our little root. And whether that value is 3, 4, 5, or 10, that's where it goes. And that is how we solve a negative fraction or a fractional indice. Let's now work through an example. We have 18d to the power of 8, g to the power of 10, divided by 6d squared, g to the power of 5. Let's rewrite this on top of each other. So we have once again 18d to the power of 8, g to the power of 10, divided by 6d squared, g to the power of 5. What we're going to do is we're going to take out our numbers, we're going to take out our common d's or common g's, and we're going to simplify them, okay? So we have 18 over 6, we have d to the power of 8 divided by d squared, and then we have g to the power of 10 divided by g to the power of 5. We're now going to simplify our numbers. So we have 18 divided by 6. We know 6 into 6 is 1, and 6 into 18 goes 3 times. So that answer there is 3. We now have d to the power of 8 divided by d to the power of 2. Our d's are the same, so we write our d. And we know that 8 minus 2 gives us d to the power of 6. This is according to our indices that we've learned previously, okay? Then lastly, we have g to the power of 10 divided by 5, which is g 10 minus 5. Our answer is g to the power of 5. What we need to now do is combine our answers. We've already simplified it, we just combine them now. So our answer is equal to 3d to the power of 6, g to the power of 5. And that's it. That's how you solve a question. That concludes today's lesson on simplifying algebraic expressions. Please let me know below in the comments if you would like me to do a separate video just focusing on indices as a separate topic, as it's very common in algebra. So let me know below, and continuing our series, I will be discussing expanding brackets, simultaneous equations, factorizing, stuff like that. So stay tuned for more, and please don't forget to subscribe, like, and share this video. But for now, thank you so much for your support, and see you next time. Bye bye.